In this video, I want to take a look at the rule for Modus Tollens. So this is the Modus Tollens rule, sometimes abbreviated as MT. So the general statement of this particular rule is as follows. What we have is a conditional. So if phi, then psi. We have the negation of the consequent of the conditional. Then we can reason to the negation of the antecedent of the conditional. So really quickly, if you take a look, we have two formulas, the conditional. We have the negation of the consequent of the conditional. So you just notice that this right-hand side of this conditional, we have on a separate line, but the negated version. So we have psi here on a separate line, which is the negation of it. So we have psi and then not psi. And then this allows us to reason to the negation of the antecedent of the conditional. You'll notice that in our conditional here, if phi then psi, our conclusion is going to be not phi, which is the negation of the antecedent of this conditional. So if you take a look at this example here, we have a conditional, if it rains, then I get wet. We could translate that as if R, then W. Let's say I'm not wet. I didn't get wet. We can translate this as not W. And then we reason to, using modus tollens here, the conclusion that it didn't rain, so not R. Notice that we used two formulas to get to this third formula, which is the conclusion. We used these two propositions on lines 1 and 2. And then the rule that we used was this MT rule, or modus tollens rule. Let's take a look at an example involving modus tollens. So line 1, you see we have this conditional. We have if phi, then psi. Line 2, what we have is the negation of this right-hand side of the conditional, the consequent of the conditional. So essentially we have not psi there. Now, if you remember, modus tollens says we can reason to the negation of the antecedent of this conditional. So this conclusion that we draw here is the negation of this formula, this subformula that's part of this conditional. So what we can do with respect to this particular proof is we can reason to the negation of this antecedent at line 1. We have P and Q at line 1, and so we can reason to not P and Q at line 3. We got this by using this modus tollens rule. And the formulas we used were lines 1 and line 2. We used the conditional from line 1, and we used the negation of the consequent of that conditional at line 2. Let's look at one final example of the use of modus tollens. So here again, we have a conditional at line 1, and we have the negation of the consequent of the conditional at line 2. So if you look at our consequent of the conditional line from line 1, it's not T. But at line 2, we have not T. There's one extra negation at line 2, which is saying that this not T is not the case. Let's look one more time at our modus tollens rule. It says that if you have a conditional and you have the negation of the consequent of the conditional, then you can reason to the negation of the antecedent of the conditional. We're taking phi here and reasoning to not phi. Now let's apply this again, this idea to our proof here. We have not S, then not T. We showed that we have the negation of the consequent of the conditional. So what would we write at line 3? Well, in our example, not S is our antecedent. So the rule tells us to negate that formula. It says to take not S and then say that it's not the case. So we'll write another negation in front of it. We'll write not S. Again, we used our modus tollens rule, and then we used lines 1 and 2 to reason to that formula.